Okay, hello everyone. Thank you for joining the session. I'm Yong-Chul Lee from Louisiana State University. In this presentation, I'd like to talk about the Beam interoperability and its automated validation according to COBE and facility management handover. Interoperability has been recognized as an important issue in our industry to achieve the successful data exchange. Domain experts use a neutral file format which is exchangeable and interoperable in heterogeneous Beam software or the processes. In terms of the facility management, the construction handover has been always struggle. So the Beam data that contains accumulated information throughout the design and construction project must be correctly handed over to the facility manager or the owner so they can efficiently utilize Beam data for facility maintenance and operation. So, for ensuring the interoperability of Beam data and FM, we use the COBE, which is the subset of the IC schema. So, in this presentation, I would like to talk about why Beam data validation according to the COBE is important and what kind of rules we can identify from COBE and how we can automatically evaluate the instance file according to COBE. I'm going to talk about these three things in this presentation. Beam models are supposed to be shared throughout the entire design and construction process, but increasing the diverse Beam authoring tools and different domain-specific or domain-based model data led data exchange or data sharing issues. So Beam interoperability is an ability or capability to kind of support useful or applicable the information in different domains, the domain levels and process levels and software application level, the three levels. There are many reports showing the financial loss because of the lack of the inaccurate interoperability. There are many kind of the financial loss shown in this kind of report. And these inaccurate interoperability typically come from the three sources: the lack of coordination of the stakeholders, different internal readiness or different technical application, or a lack of the robust standardization. To enhance this interoperability, we use a neutral file format. IFC is one of the most popular neutral file format we use. And we define the module definition, which is a subset of IFC schema. So the module definitions is defined to reflect the domain-specific data exchanges. So one module definition can contain several exchange models. One exchange model is a requirement of one particular data exchange process, and the data exchange models consist of the concepts. Concepts are iteratively reused to define the exchange model, and each concept has the information for describing entity, relationship, or properties, and each concept contains the attributes, this kind of some required information for data exchange. So each attribute can be used as a rule set. It means we can use this concept attribute to map the native data, such as the Revit or other View application model data. We can map that native data into IC, but we can also use this attribute to evaluate whether the translated IC data contains the required information or required attribute or not. I'm going to talk about detail in the following slide. COBE is one of the MVD defined for exchanging beam data and FM. So, as a big stream of current practices in the facility management, it's a key to integrate the CAFM or CMMS data into beam technology, so they can increase efficiency of commissioning or the handover of facility information for the operation and maintenance. So we need to identify whether IC instance file contains required information regarding COBE or not. And we need to see whether their IC interfaces accurately translate the native beam model into the FMIC file or the spreadsheet, FM spreadsheet. But currently it's not easy to evaluate whether the beam model or the IC spreadsheet contains accurate information that satisfies the COBE standard. So there are a lot of semantic errors and some omissions. Actually, the problem comes from the three things. First one is the IC translator. Every beam authoring tools has an IC translator including and exporting features, but sometimes the IC translator has some error. This is the first issue. Second one is the modelers, the building modelers, some inefficient kind of the modeling technique issue. And last one is the standard issue. So some people think COBE cannot cover the current FM the information. So these are kind of three things can be an issue. So from the perspective of software vendors, they need to evaluate whether their IC translator can accurately import and export the IC file according to the COBE. And from the perspective of domain professionals, they need to identify whether the IC instance file or the instance file can contain required information they need for the building asset management or facility maintenance. So in this the research, we propose the automated rule checking framework. Automated rule checking framework means if we establish automated rule checking platform, it can be iteratively implemented throughout the design and construction phases. In these days, facility managers are encouraged to get involved in early design phase, right, in order to reflect a facility management requirement from the early design phase. So this kind of the automated rule checking platform can be iteratively implemented to evaluate whether the design phase, the model, or construction phase model can reflect the facility management requirement or not. So we propose, in this presentation, I'm going to talk about the rule types and the validation, the platform. We use the iStack. iStack is developed by Tim Chinman. iStack was used to develop JC3 and JC4, and iStack is some open source program that can support the MVD documentation and the validation. I'm going to show the detail in the following slide. Here's the data flow of this research. We identified COBE specification, and we modified the specification, and we developed some rule set on top of the iStack, and we can generate the two types of the validation report from the iStack. One is the user interface report, another one is the HTML report. Actually, this is a spin-off project. I was involved in the precast concrete, the MVD development in US, and we identified around 100 concepts, and we identified the particular rule set. It's about 13 rule sets, and we developed the rule function on top of the iStack, and we want to use this function for evaluating instance file for COBE. So this is and we define the checking logic represented in first order logic. It is the formalized representation for each rule checking the types and implementation. Here are the COBE requirements. COBE has 28 exchange models, and there are the 16 concepts. We look at each of them, and these are the particular information COBE requirement has. And we identified 4 types of rules: the uniqueness, and semantic accuracy, and relational references, and general syntax checking. I'm going to show you the details. First one is the uniqueness. COBE has some required information. It means some attributes should be unique in the project level. So this iStack rule checking feature can evaluate that the attribute is unique or not in the one Arch model. The second one is the semantic accuracy checking. COBE refers to CSI omni-class taxonomy, and US follows the omni-class, and UK follows the uniclass. So there are some the semantic attributes. This kind of the information can be contained in the parameter, the categories, and according to that, the semantics, these tools and functions can evaluate each instance file to check the instance file to satisfy this semantic information or not. Third one is the referential relationship checking. Each entity or relationship has the particular structure, schema structure. So this function can evaluate each entity and the properties or relationship has the structure, relational structure, according to the COBE, the requirement or not. And last one is syntax checking. So iStack, evaluate the general syntactical the issues. So it is the fundamental syntactic issue defined in the IC schema level. So we use the validation, the sample. This is the hospital validation sample that contains the spatial information or some other facility management information about the hospital. So this is the iStack, the validation, the interface. It shows the information passed or failed. The failed information, failed attribute or concepts are represented in red. The left-hand side, and right-hand side is the IC instances related to each concept. So when you click on the IC each instance, and you can look at this kind of scan, the relational the diagrams, what kind of the relational, the entity are, uh, what kind of the entity have the problems. So this is the HTML report, so it's easy to read and easy to understand. So about the validation, about the past affairs and instance. So complete the specification data aggregated during the design and construction the phases is invaluable for facility manager who manage the complete building over the decades. So in this research, we proposed the automated validation framework, and we proposed for the rule types identified from COVID, and we believe this automated tool can significantly enhance the data exchange, the processes between the constructor and the facility managers. Without this kind of tools, the facility managers and the owners can be left without the accurate the facility management and operation data. Thank you.